সেটা তিনি অটোক্যাড করেন।
Şey diye bir Oh, in the middle.
ওকে, একই খবর।
Hi, everyone. Thank you for joining us today. We'll be waiting 10 minutes for more people to join, and then we can begin shortly.
Hello, everybody? Hello,
Hello, hi.
hello. Grace, how are you?
Mm, Good.
Johannes, how are you? And everybody, good morning.
Good morning.
Good morning.
Welcome to our webinar. We should start within the next 3 minutes. Grace, you can guide us, and Patrick.
Okay, thank you. We shall be starting at 11:10 in about 7 minutes, just waiting for a few more people to join so that we can begin together.
Said 11 that. Yes. The one that I sent today. Now. No. Just now. Yes. Yes. And sent 11:20. I have an online meeting that I want.
So hello everyone, thank you for joining us today and taking your time to come to this webinar. Hope you're well wherever you are, and a very warm welcome to everyone who has managed to join us today on the webinar entitled Harnessing Earth Observation for Wetlands, a deep dive into the Dunia platform. So my name is Grace Akoth, a GIS analyst at RCMRD, and on behalf of RCMRD GMS and Africa program, and at our partners at Dunia, I sincerely thank you for taking the time to join us again. I will be your moderator for this two-day webinar, together with my colleague Johannes from GeoVille, who will be guiding us through today's session on utilizing Dunia platform for wetlands monitoring, and on tomorrow's session as well. So this webinar has been organized under the framework of GMS and Africa program at RCMRD, which is an African Union initiative being implemented with the support from the European Union, and that continues to empower institutions across Africa to harness Earth observation for data for decision making and sustainable development. So I would like to invite Mr. Murage to officially open the webinar. Over to you, Mr. Murage.
Thank you, Grace. My name is Joseph Morage, and I want to appreciate all of you who have joined this webinar for 2 days. We'll be sharing with you, together with our Dunia partners, the utilization of data sets to help us access the platform and much more to use. At GMS and Africa, our main role is to bring partners together and to bring stakeholders together and showcase what Earth observation can do using various tools. I believe a number of us have heard about Dunia platform, and for the next 2 days, starting today, the emphasis will be how to actualize utilization of this platform to meet your own specific needs. All of us, I believe, we have had Dunia, and I know there are challenges that might be addressed in this webinar, and we are willing as RCMRD and GMS and Africa Project to support all of you. And therefore, I want to take this time and welcome all of you, and thank you very much. Thank you. Over to Grace.
Thank you, sir, for the introduction, and we are delighted to have all of you as our participants in this webinar, because this is a common interest to all of us, talking about wetlands and how we can manage them using Dunia. So over the next 2 days, as Mr. Mrage has mentioned, we'll be taking a deep dive into the capabilities, practical applications of Dunia platform, and even sharing ideas and contributing to the stronger conservation and management practices that we can have for wetlands. So I encourage all of you to actively ask questions through the Q&A, even the chat section, so that we can see how best to answer. And also I've shared a feedback form where we can fill in so that we can know more about you and get feedback as we continue. So with all that said, it is my pleasure to welcome our speaker for the day, Johannes, to introduce himself and even take us through the next section. Over to you, Johannes.
Thank you, Grace. Yeah, welcome everyone. It's nice to see that we have quite some participants. My name is Johannes Schmid. I am the IT Service and Operations Manager at GeoVille. That's a company in Austria. And GeoVille is mainly responsible for Dunia. A webinar in these 2 days will consist of a general introduction to Dunia, which is going to be today, including the registration and the first dive into the sandbox environment, just for you to get a feeling. And I will also ask you in between how much experience you already have with Dunia, so we get a feeling of what your experience is to adapt the training that will happen tomorrow. For tomorrow, we have planned one or maybe two speakers that will present what you can do inside the Dunia sandbox to create pretty nice water wetland products and yeah, experience what you can do with Copernicus Sentinel data. So let's start off. You should see my screen. So first, why Dunia? What is Dunia all about? For those of you who don't know, the big goal of Dunia is to getting more Africans to use the freely available Copernicus satellite data. So the European Space Agency is publishing freely available satellite data, highly with a high temporal resolution actually, and we saw that that data is not used as much in Africa as it is being used in Europe. And this project is kind of like a collaboration effort between the African Union and the European Union to support the capacity building in Africa to use that data that we have already. So we want to get more users of that data. So the goal is that Dunia is then not just for experts, but also for beginners to get more people involved into Earth observation. So to get a first feeling of your experience, please scan this QR code with your mobile phone. You will be then redirected to a Slido survey. And we will do that survey interactively in this presentation. So with the next slide, you will get your first question and we see the results together. So just scan that code, open the link, and wait a second until we continue. Okay, I guess everyone should have scanned the code. I'll give you maybe another 10 seconds for that, just to be on the safe side. So then I will start with the first question. Have you ever worked with Dunia? You will also see the QR code on the top left in case you haven't used the code yet. Just to get a feeling of how many of you have worked with Dunia so far. Oh, that's so congrats to you. That's the most responsive poll we had in a long time. So we already have 20 voices. That's pretty nice. So 85% have already worked with Dunia, 86%. Great. That's awesome. Still getting responses. Wow, so I'm really surprised that we have so many Dunia users. I see also someone saying, what is Dunia? That's perfect then, because this presentation will be perfectly fit for you. But I will probably be shorter on a few of these slides and dive deeper into some of the features. So actually there are some more who don't know what Dunia is. Oh, sorry, I think I misunderstood. We have 77% who have never worked with Dunia. just 13%. So this is great to have this introductory presentation for you to get to know Dunia before we actually start with a water wetland webinar. So we're still getting some results. 35 now. Do we stay with 35? I guess so. So we have 77%, most of you who have never worked with Dunia, and a few say, yes, I've worked with, and a few say, I've even no idea what Dunia is all about. Let's continue. So to give you a brief definition of what Dunia is. Now you know the goal, what we try to achieve to get more users into satellite data. So Dunia is a free, all-in-one and easy to use data access, processing and dissemination platform. So the all-in-one is explained already. So it is data access. You can get the data easily. Then on top of that data, you have the environment tools to process them, to develop your own applications. And in the end, you can share your results with the community or with your colleagues, and all that for free. So we thought, okay, the biggest issue when trying to start with Earth observation data is, first of all, you need the knowledge, right? This is one of the reasons why we have this training, this webinar, to get to give you help and give you an understanding of this, the data type, the satellite data, how do you read it, how do you understand it, how can you make use of it. And then if you have this understanding, the biggest issue is that you actually need a infrastructure for that. So you need some kind of a laptop, computer, or cloud infrastructure to work on. And if you have that, you need to install the GIS, the Snap software, whatever software you use, or you need to install Python, you need to install all the modules that you're using. So you get into this dependency hell, and this is a lot of time, effort that you need in the beginning just to have a working environment where you can start programming using satellite data. And then you need to download all the data that you need to have to start. So you see there is a huge step from having an understanding until actually getting started to work with that data. And with Dunia, we try to make this as easy as possible, that you can, if you get this first understanding, that you can just start programming. And also this first understanding is what we try to deliver as well. So with examples, we try to help you get an understanding of the data itself, which data to use, how this data looks like, and so on. So it is actually really made for beginners. So who is Dunia? Who is creating that? It is not just GeoVille, the company I representing. It is also the CS Group from France and Romania, our data provider, Cloudfaro from Poland, and the German Aerospace Research Center. Tomorrow we will hear from Cornelia Zygar. She is a researcher at DLR, and she is going to have one of the presentations tomorrow. But it is not just these companies who are actually building Dunia. It is, as we heard already, the GMS and Africa Consortium, the African Union. We have the RCMRD, we have AfriGeo, we have all kinds of universities, institutions, NGOs, and other actors and stakeholders that help us shape Dunia. So for the 13%, I think, that have used Dunia already, we'd like to hear your feedback. Whatever you think a nice feature would be to introduce into Dunia, we are happy to add it or change Dunia according to your needs. So Dunia is not just made for Africans, but is also made by Africans as well. So we actually really use your feedback to include it into Dunia because we actually want these features to be used. So that's the most important part. So as you might know, Dunia is Swahili for world, and I think this slide shows why, because we actually want to include everyone to co-design Dunia together with us. And let's go to the next question now. What type of organization do you represent? Are you part of an academic institution, a university, doing research? Are you part of governmental institution? Do you work for a private company or an NGO or something else that we didn't mention in these 4 options? I see already 4 voices by, or even 5 by governments. That is very important because mostly we have a lot of decision makers sitting in the government, and here people actually want to use satellite data, but not just the satellite data, and they don't really want to code themselves. They just want to get the information out of the satellite data, right? So we also need solutions that just give us information based on Earth observation data without the need of actually coding, downloading the data, getting an understanding. So we try in a next version, in a next release, to also add features for decision makers that they get the output of Earth observation data. So not just the raw satellite data, but just for example, the affected population by a flood event, and to get this information and decide based on that result. So basically statistics, regional statistics based on Earth observation products. So your feedback is very well needed. So for those of you who are from the government, please leave us a comment or feedback after this webinar, what feature you would like to have. That would be very important. Of course, every other sector is also as important. Academic and research is very important because this is where we have the new upcoming potential, right? From Africa, who is learning on how to use Earth observation data. So you're the beginners we mostly try to target. So if something is not clear enough, or we can get have a better tutorials, better teachings of certain topics, then your feedback is very well needed as well. Same goes for NGOs and private sector. Whatever features you think are necessary to complete your work, APIs to or on other interfaces to connect with your own platforms and interfaces, please let us know, because there are a lot of interfaces, not just the UI, but also APIs to connect to support a better data access. So I think we had about 36 voices last time. We have 32 now. I think that's fine. We see most of you are from academic research, then quite a few from government. So about, yeah, less than 10 people. We have a few from NGOs and a few from others. If you want to, you can also leave a comment in the chat for those of you who are from another institution to know what kind of institution. And of course, also a few from the private sector. So very interesting. So in our first slides, I told you the definition of Dunia. We have the data access, we have the processing, and then we have the dissemination. We always call that build, discover, build, and exchange. if you visit our homepage, you also see discover, build, and exchange. So you have discover for discovering all potential input data sets, the satellite data, how you can use it, products that you can derive from satellite data, and on top of that, you have the build section to actually create your own results, develop them, process them, and in the end, the exchange part to share them. Now, the streaming solution is part of the discover section. So to see how you can access satellite data. This streaming solution is actually tailored to African users. Why? Because there are a few areas where you have quite a bad internet connection, low bandwidth internet connection. In Germany, we have that as well, by the way. So we know what we're talking about. If I go home, I rarely have internet. So this is a very good solution to actually get this data, which is quite big. One scene is about 1 gigabytes in size. And we have a new compression method. So to download it, it's faster and you need less disk space for it. Let's watch this video. You can select a satellite data set, for example, Sentinel-2, that's our optical data, and you select a year. And after that, you can zoom into an area of interest and play a video, just like Netflix, so you can watch a video of the satellite data in your area. And if you're interested, you can stop the video. In this example, we stop on the 19th of January 2024, and we download that image as a file, as a true color image GeoTIFF file. Of course, this solution is now just, it looks nice, it's a video, right? But of course, for development, you need a different solution. So if you go to our Dunia website, and we will do so together later on, you see that we do not just have this UI solution, but also an API solution. So you can get all the images via API calls or via a Python toolbox. So this enables you to get the data in a different kind of way, just extracting images from streams, which means less size of data and a faster download. It is not just true color images that you can download, but also different bands, different indices, and not just Sentinel-2, but also Sentinel-1 and others are upcoming as well. But we'll have a closer look at that later as well. So now the one download solution, the streaming solution, is really if you're just interested in data access. Let's say you're a private company or an NGO, you have your own solution, but somehow getting the data from your current provider is not that reliable. You want it to be faster and more, maybe also more easy, then this solution would be great for you, because that is actually just for data access. Now, we have two solutions in place to actually work with the data. That's our Jupyter Sandbox and our application hub. Both of these solutions have an underlying location where all the data is stored. So with these solutions where you actually work with the data, you don't require any data download. You actually code at the same location that the data lies. So we save a lot of time when developing in the sandbox or in the application hub, because the data is already there, no download needed, right? Also no streaming download needed. It's a nice interface where you can just view the data that's already there, search for it, view it, work with it, create nice results. So what is the difference between the sandbox and the application hub? The sandbox really gives you an interface, a Jupyter Hub interface, or a virtual desktop environment to develop and create new data sets. So You can use a GIS software like QGIS or the Snap software on the one hand side, or you use Python and code yourself and create nice results. On the other hand, we have the application hub, and that one is made for actually processing your results instead of developing them. So if you can, as you can see in this screenshot, you have a workflow builder, so you can merge a few tasks and combine them and then execute that workflow for a bigger area of interest. So for example, if you have your own precision farming workflow, you could execute it for different areas just by having one click. And you can also schedule that one. So if I say I want to do a flood monitoring every day, I want to see if there is a flood in my area, I can say inside the application app, please execute that workflow every day at 6 a.m. in the morning to see if we have new floods. So those are the two solutions that you can do. And to get an understanding of your coding skills and to get an understanding, especially for our session tomorrow, I would like to know if you have any experience with Python so far. So maybe you're just getting started with Python. Maybe you know your way around, so you're intermediate. Maybe you're even a pro, or that, and we have that quite often as well, you're more like the GIS kind of person. You like to use ArcGIS, QGIS, maybe other software like Snap software. All that's valid, and we have solutions for all of you just to get a feeling of what our audience looks like. So I see we're quite having almost everyone, rarely a pro, but that's fine. We rarely see that one marked anyway. And we also see we have more JS kind of persons. That's very, very good to see, because we might add respective examples then tomorrow as well. Okay, still more than almost 50% are GIS, prefer GIS over coding with Python, I see. It's, I think, like 50-50. Some are getting started, know their way around. It's about 50%. Oh, even more, 56%. So it's like 50-50 almost. Okay, that's great to know. Thanks so much. So how does the sandbox actually looks like? So let's forget about the application hub for processing, because we actually want to develop first, right? We want to be creative. We want to actually explore the data. What is Sentinel? What is Copernicus Sentinel data all about? How can I use it for water and wetland monitoring? And to do that, we focus on the sandbox. As I said, the sandbox for development comes with two features. One is the Jupyter Hub that you can see in this image. I will just play this video right after my explanation, where you can open up a notebook and code yourself. We'll go dive into that later. For those of you who have no Jupyter Notebook experience, that's fine. We will explain that in the beginning for you to understand the big advantages of coding with notebooks instead of a regular IDE. And on the other hand, we have a virtual desktop environment. It's also quite nice to use both, because, for example, if you use machine learning or AI, you want to create your own training sets, and you can create your own training points using GIS, using QGIS, and then using these points that you have created within your notebook for actually training your machine learning or AI model and predict it later on. Or you create a pretty nice result in Python and you don't want to use just matplotlib to explore your results, but actually just write it to a file and load it to QGIS to actually see and dive deeper into your result. So let's play this video. As you can see, let's click on one of these notebooks. These notebooks are not just code, but also titles, images, text. So you make a story out of your code to explain how and why you actually did it that way. And as you just saw, we also have a nice plugin to actually search for the data. It's called EUDAC. We will go and explain that tomorrow. Maybe today, let's see how much time we have left, but we will do that. And this is the virtual desktop environment where you can open GIS. You also have Snap on the left side, or RStudio, so you can use all that to then do as you are used to. And with that, you can, of course, also use all the data sets available. But I would recommend you to use our EUDAC feature inside the sandbox to search for the data first before you actually use it in GIS. But we will go and show you that tomorrow as well. And finally, the last part, our marketplace. We developed a marketplace. It isn't used that much so far, but I think it is a pretty nice feature because it offers a interface for you to share your results with the community and increase the capacity. So help each other. So you see, for example, you have a search feature where you see different services for agriculture or wildfires, and there are other categories as well. The items in each of these categories can be either an application, as you can see in the screenshot. So we have two applications, Sentinel-2 soil indices and burnt area application. But there is also the opportunity to share data sets, so results that you have created. For example, NDVI for South Africa 2024, and so on. If you click on one of these applications or data sets, you get a bit of more information, the title, a description, a review marked with stars, and you can just click a button, order application. It's for free, so you just order it and then you get a link, and if you open that link, you will be redirected to the application hub to just execute it yourself. This is how it looks like. You can scroll through the categories. For example, you see the burnt area. If you click learn more, you will be redirected to the details page where you can order the application. You see the review in stars, as I explained. You see who posted that. In this case, it's the admin Dunia user, and you see other products from that user. And of course, you have a more detailed explanation of the service and an image. And if you experience a problem with the service, it's not working as you expected, and so on, you can always report a problem in the bottom right corner by pressing the report a problem button so that we know which services, applications, or datasets to investigate to see why they're not working. So thanks for listening. This was the first introduction presentation. You see we have quite a few users everywhere in Africa now. This is not the actual map of our users, but it's still similar. So we see most of our users are from Kenya, from Uganda, from Tunisia, from South Africa. So from north to south, users everywhere. That's quite nice to see for us. And as I said before, your feedback is what makes Dunia a great platform, and hopefully we get better with your feedback. So please visit now our homepage, the platform, which is called dunia.isa.int. And we can do that together. Dunia.isa.int. And you see the homepage with the big slogan, discover, build, and exchange, as I just explained it to you. You can scroll down, you see the latest news, and you get the entire story that I have explained to you in this presentation. Of course, I think this presentation will be recorded and you will get it afterwards anyway, but for a quick repetition of what I've said, you can also scroll down and you see all the features of our discover, build, and exchange sections. If you ever experience issues, please, on the bottom left corner, we have a support button. If you click it, you can write a ticket. We will try to answer it as quick as possible. And before we go on, because a lot of features can be just used if you are registered, we click the sign up button. Maybe to just a note beforehand, if you prefer French over English, on the top right corner, you can press the flag and the homepage is automatically translated from English to French and the other way around. So let's click the sign up button and register. The only information we need from you is basically your name, your password, your email address. You will get a confirmation mail and then you can start right away. There's some additional information that we would like to have but which we are not going to share, so be ensured that we keep that private. It's about your job description, organization name, organization type, and country, just to know how many users do we have from research, from governments, and so on, from which country, to get this nice looking map of where our customers are. So I think this is pretty nice for us to actually know our users. Of course, a captcha to say you're not a robot, and please accept the terms and conditions. You can also read it, so Dunia is free, and we keep the rights to remove a user if he is using Dunia for any other purposes that are not allowed, not using Earth observation data and just doing something else, for example. It also says that your data is protected. So you're able to upload your own data to the sandbox. The sandbox is a private working environment. Nobody else but you sees the data in there. So if you have sensitive information and you store that kind of data in the sandbox, nobody else but you is able to access that data. So please, this is also something that helps you. And after a successful registration, you can click the sign in button next to the sign up button. Now we'll do that now. Click sign in. Even you can also sign in if you have a CDSE user, the Copernicus Data Space Ecosystem user. I guess most of you don't, but in case you have already experience with European projects, or you hear CDSE in the future, CDSE is basically our backbone. So the data that is being used from the CDSE. So we align. So yeah, I just click sign in, and now I see my credentials, my not credentials, my initials on the top right corner. I see that I'm logged in, and I can start with all the services that Dunia offers. So how does our journey begin? I will maybe give you another 2 to 3 minutes to complete this registration process, because then you can actually focus on what I'm doing, and if you want to, you can do it at the same time, because then it's maybe more fine for you. If I show you the streaming service, you can click it yourself to have seen it. It's easier for learning as well. So please take your time and do the registration process as I just showed it, and log in afterwards. The confirmation mail should come quite fast. If you experience any issues, please just write to the chat, but registration should be quite fast.
Hi, Johannes, we can't hear you.
Yes. Okay, then I will just continue. Sorry if my camera interrupts. Sometimes my camera is just switching off. So I guess you have all logged in now, and let's discover first. Let's go through. If you are interested in getting a better understanding of our datasets, you can go to the Discover Dataset section. You see the different Sentinel missions. You see other missions that we support, like NVSAT, SMOS, the Landsat fleet, and so on. We also offered administrative boundaries, geo-boundaries for statistics. If you click Learn More, you get a very brief explanation of what the data is all about. For example, Sentinel-1 is a radar satellite, and the big advantage of radar is that it penetrates clouds, and we do not have the issue of cloud coverages, right? And it is used a lot for water, wetland, maritime monitorings. So, and or a flood monitoring, for example, as well. So in our case, for the sessions that we will also have tomorrow, Sentinel-1 is a crucial input data set. Same goes for Sentinel-2. That is also very important. That's the optical data. It is also very much used for land cover classifications, and therefore also water and wetland monitoring. Since it has cloud coverages or is affected by clouds, we'd like to use both Sentinel-2 and Sentinel-1. There is also Sentinel-3. This one is very important if you if you want to monitor the surface topography of the sea surface, or the temperature of the ocean and water, and also, for example, in case you want to monitor or map the water quality, sedimentation, algal bloom. This is where you want to go with Sentinel-3. Sentinel-5 is more about atmospheric inputs and so on. I will not dive into more detail. But I can also search water, or no, I think it's just the tags are different. Let me see. Yeah, land surveys, ocean surveys, okay. But if I search radar, for example, then I guess I get Sentinel-1 in my search. So let's go to our wiki. So we said in the beginning we want to build a knowledge, right? So I just showed you the data sets where you can dive deeper into, but we also have a wiki that can support you in getting a basic understanding of what satellite data to use. It does not just show you when we have new trainings or our news, but it also gives you a basic understanding. If I go on the main wiki page, there is a button getting started, quick start, right? It's just the first link that you see. And if you click that, you will see some case studies and applications. And that's pretty nice because now, for example, we are in land monitoring, or in maritime monitoring, emergency management, atmospheric monitoring. So let's say I want to know about flood events because we're in water and wetland, right? So let's go to the floods section. If I click it, you will be redirected to the Sentinel-1 applications, and you get a explanation of why, how Sentinel-1 can help you with monitoring floods. You get a more detailed understanding, explaining the different bands, the different wavelengths, the different polarizations. It is indeed important because you get an understanding what these letters mean. If you download and work with Sentinel-1 data, for example, you often see the polarization information, VV and VH, and to actually make use of that information and make use of Sentinel-1 for water and wetland, you need to understand these polarizations as well. We're going to explain them to you tomorrow as well, but just in case you want to repeat it, you can use the wiki to get this understanding. So let's go back to Dunia. We've seen the wiki, the data sets for an understanding. Let's go to our streaming service that I've explained to you in our presentation. If you click Discover Streaming, you will be redirected to our streaming landing page, we call it. In this landing page, you get all the information you need about the streaming. You get a video introduction, some videos that explain to you how the streaming works, as I did, maybe in more detail. It also gives you an introduction to our toolbox that you can use with Python, and you see some links to our API, to our Python toolbox repository, or to a PDF tutorial for you to get a better understanding, or to use either our API for a platform integration or the Python toolbox if you want to code with it in your local environment. You see some features. It's simple to use, it's faster, it has a better data compression without losing quality, and that's all explained here as well. And if you want to watch some nice videos and do what I've just showed you in our presentation, you can simply click the Open Streamer button and you will get redirected to our streamer. Here I can choose between Sentinel-1, Sentinel-2. Let's stay with Sentinel-1 for the current year 2025. I apply the settings, and I will just zoom to a location. Let's go to this river outlet. I click on that tile. Those tiles are all Sentinel-2 tiles. So if you have never seen these codes, 28 PCU, just forget about them. They are basically the IDs of these regions. So this tile region is called 28 PCU. If you always want to keep and stay in the same region, you might get to know them by heart at some point. So now I've clicked the tile, and you already see this tile looks different than the others because this video has already loaded. And I can just press the play button and see how see all the satellite images of the current year 2025. If this video is too slow for me, I can just increase the speed and see how it looks like. It's pretty nice to see how the sedimentation process develops in this river, and we also see when we have most clouds and the rainy season here as well. If I'm interested in a specific image, let's say this one from 19th of March, because it looks quite nice and cloud free, right? I can also zoom in. I can just click this photo icon to download this single GeoTIFF. You see the type is a true color image, so it's red, green, and blue. The result will look the same than what I see now. And I can also choose the target coordinate reference system. In our case, it's the default Mercator protection. If I'm interested in more than one time frame, I can also click time series, and I can select the start date and the end date as well to download more days at the same time. Of course, some of you are not interested in a true color image. Some of you actually want to code, create their own indices like NDVIs. This is also possible by using the 10-meter bands like blue, green, red, and near infrared. The 20-meter bands, those are the different red edge bands, and also the 60-meter bands, which is water vapor and coastal aerosol. But we also offer the spectral indices, quite a range of them. The NDVI, the NDWI, which is quite important for us. It's the normalized difference water index. It shows us where we have water and where we don't. But we have also other indices. For example, the modified normalized difference water index, which is also quite nice, or the normalized difference moisture index, which is very important for wetland classification. I can just click that and press start download. Since it's an index, this index will be calculated on the fly. So I see currently we are downloading the two bands. Now the first band is downloaded. Now the second band was downloaded. Now we decompress these two bands and compute the index. This might take another second, and we already have our result, and I can watch it in this viewer. Of course, this is just a regular photo viewer in Windows, so I don't see much. But if I would watch that in QGIS and select some value ranges and color settings, then we would get a pretty nice moisture index result. So this is how the streamer works in this user interface. And as I said, you can also go to the streaming feature and explore the API by clicking learn more. So you can get all the Sentinel-2 tiles, the metadata, the bands, and get the streams. Or you check out our toolbox to actually code it yourself. We have some examples. We have Jupyter notebooks. We have an very detailed documentation. And I will skip. Let's go maybe quickly to the marketplace before we dive deeper into the sandbox. So in the exchange part, you can click marketplace and you basically see what we have seen in my presentation, the different categories. Every category might have different applications or data sets. I can click learn more and see more detailed information about the service. And if I click order application, I see, thanks, the order was successful. Visit the personal application hub. And now I will be redirected to my application hub and can execute it in there. But we will focus on the sandbox, and not the application hub. So we will go to the build section and click Dunia Sandbox. Similar to the streaming, we will be first redirected to this landing page, which gives you basic information, the one I already presented. You can read the docs, read the features, but since we have a webinar, I think I'm able to explain it a bit better to you. So if you launch the sandbox, it will open up a private working environment. Every one of you is getting 4 CPUs, 16 gigabytes of RAM, and 50 gigabytes of object storage. Whatever you do in this working environment stays safe and only you can see it. So if I now click Launch Sandbox, it opens up a new window and my own environment is starting up. This is dynamic, so it will always start up when I enter the sandbox and I'm logged in. This can sometimes take a minute. In this case, it's already done in after 10 seconds. Since we have quite a few users here, we'll see whether it works great if we have 100 people logging in at the same time. Rest assured, for tomorrow, this will work for sure. I just sent a reminder to my team that it will also work with that many users in parallel without registration. So this is how it looks like when you go in. You see the launcher, you see a file explorer on the left side, and that's basically the same that video in my presentation. So let's say I want to upload my own data set. I can click upload files up here and just upload, I don't know, some kind of image that I have. Open, and it's uploaded and I can watch it if I want to. Of course, I can also download whatever I've created in my sandbox. So if you create something nice, that doesn't mean you can only use it in the sandbox. No, that would be very mean of us. You can use all the notebooks that you have created, all the results that you have created, simply right click and click download, and it is downloaded to your computer. We also have a file browser here. It is a bit more user-friendly for uploading and downloading if you prefer this one over the solution I just explained. So I wanted to explain you the big advantage of notebooks. So for those of you who have never coded, this might be completely new anyway. For those of you who have Python experience, you will get to know the advantage of notebooks. So in an IDE, so a regular program like PyCharm or Visual Studio Code, which we offer here as well. If you click it, you get your own Visual Studio Code interface. If you prefer that, that's fine as well. But the advantage here, so usually you code like that. Import, you have your imports of your libraries, and you say print hello Africa, and then you execute it, and that's your entire code. You execute it once and your entire code's running. So in here, I can put all my code into different kind of cells. So I can put all my imports, import numpy, into one cell. I can do some print here. I can do a new cell and do, I don't know, even a bash command to see what is in my current directory. So first advantage is all your outputs, but also errors are visible and stay visible. This is quite nice because you can code and see all the outputs in between. It's pretty nice for debugging purposes, but also for documentation for others to understand your code. And if I say for others to understand your code, this comes with another feature. You can change your cell from code to markdown and just write in text. This is my documentation. So you can add documentation. You can even add images. Lake Chad. Let's check out Lake Chad. It's a great example for water wetland conditions in Africa. I can do a new cell markdown and I just paste that image and I see I can include that here. And that's pretty nice, I think. If I'm not interested anymore, I can also right click, delete cell, and you also see the shortcuts by pressing the letter D, like delete twice. You can also delete it. So there are quite a few shortcuts, keyboard shortcuts that make life easier here. So what do we have? It's easier for debugging, and it makes your code, it creates your code to a story, and that's pretty nice. Not just for documentation, but also for others to understand why did he do it that way? Why is he using Sentinel-3 for algal bloom monitoring and so on? So let's say I am, for debugging purposes, I am doing a command and I try to search for something. I get an error. Name glob is not defined. So now I see, damn, if I would have a regular code, I would have to solve that issue and run my entire code all over again. In Python, Jupyter Notebook, I can just import glob in this cell. I rerun this cell, and then I can just rerun that cell. Module object is not callable. Sorry. From glob import glob. And if I execute it, it works. So I did not have to re-execute that print statement or that statement or all the code that would be in between. I just have to execute my repair code and the one where I got the error, and this makes coding way faster because I don't have to re-execute my entire code the entire time. So that's a huge example, a huge advantage of notebooks. Let's go to the desktop environment. So in the launcher, you can also click desktop, and this will open up a new tab with your virtual desktop environment. In here, I can click applications, education, and then I see Grass.js and Qt.js. Fortunately, we cannot offer ArcGIS because that needs a license, and licenses are extremely expensive. Of course, we cannot offer them for free. So this is why we only have Grass.js, which is command line based and a bit more less user-friendly than Qt.js, but it has pretty nice features, and also Qt.js. And we also have the Snap software. The Snap software is made by the European Space Agency and comes along with a lot of nice features that Qt.js does not offer. For example, if you work with Sentinel-1 radar data, the thing you need to do in the beginning is pre-processing. You need to pre-process raw Sentinel-1 data before you can efficiently use it. You have a section called radar data, and there you have a lot of tools like applying an orbit file, radiometric noise removal, thermal noise removal, sorry. You have speckle filtering. All these tasks are required for having a nice pre-processed radar image. And we come to that in tomorrow's session as well. So these features, like applying an orbit file, you will not find that in QGIS. But if you are familiar with remote sensing, you will see the big advantage that Snap offers to you. It might happen that Snap is not powerful enough with the resources you have, but you can always hit the support button to request more resources in case you need them. There will be a request more resources button in the future. For now, please just hit the support button and write us in case Snap software is too slow or is not powerful enough for your tasks. And this is where I will stop today. This is the sandbox. This is Dunia. And we will now have enough time for Q&A. And it's also great for me to get some feedback and to know what you're waiting for, especially for tomorrow's session, where we will dive into the Jupyter Hub, not just the code part, but also the desktop part to give you some examples on how to monitor water and wetland. I now see there is already a raised hand by Moepi Pulau. I hope I pronounce it correctly. Otherwise, I don't see any Q&As, questions in the Q&A section. You can always do it here as well. Let me see. I can accept your microphone. Now your microphone is allowed, Moepi, so you should be able to unmute yourself and ask your question.
Thank you very much. Am I audible?
Sorry, could you repeat that, please?
Am I audible?
Yes, you are.
Yeah, so thank you very much. I'm here in the Mountain Kingdom, Lesotho. So I tried several times using it. You see, sometimes it comes too slow such that it even crashes while I'm doing the analysis. How are we maybe this time around solving the issue of the slowness?
Okay, if you say it crashes during your analysis, could you give me more information? Is it crashing in, are you using Jupyter Hub code? Do you use the desktop? Is it crashing before you even start the sandbox? What exactly is happening?
Yeah, sometimes it will not even load. It will crash even before I start. But sometimes it will allow me to log into the online platform where the analysis are being undertaken. But you see that while I'm trying to analyze, yeah, sometimes it's just a freeze.
Okay. So about the sandbox crashes, we are well aware of the past ones. So please in future also write a support ticket, because every time this happens, we notice that and we're solving that. We also try to currently develop a sustainable fix. Most of the time it's because the amount of allowed data you store was exceeded, and then you are not able to enter your notebook anymore. So this is an issue that we will solve so that this does not happen anymore. If it crashes in between, so this is something that might happen if you work with Jupyter Hub. This is an expected behavior that we cannot change, and that is also correct. For example, let's say you have a super huge sandbox, super huge notebook, and it has hundreds of cells. Let's go check out some. Let's say I execute this entire notebook, and then I go up, I change the area of interest, I execute it again. I want to change something, I execute it again, and I execute it again like 10 times, 50 times. Then you might get the pop-up window. The kernel has been restarted. This happens if you overload the current sandbox, because it stores everything in memory. So all the results that you have in between, Hello Africa, my LS result, and so on, this is all being stored in the background. If that storage gets too much, it will restart the kernel, which means you just need to re-execute your notebook. This happens if you stay with the same notebook too long and you execute it too often. Then you might need to split it maybe into different notebooks, or just re-execute it after playing around. And yeah, as I said, sorry about the inconveniences if it crashed beforehand. So it might happen then if for the others, if you didn't know yet, if you click sandbox and you launch the sandbox, this blue bar, it might turn red and say there is an error. Please always go down, support, write a ticket. We will fix it as soon as possible, and we're currently working on a fix to solve if you have stored too much data. So it can happen you have a code and you store all the data here where it's supposed to be stored, and you read and you exceed the 50 gigabytes that you have, then you might not be able to re-enter your notebook because the storage is completely full. We also offer a file browser, a file sharing repository. You can either, as I said, you just download your results after you're done, and then you have free space again, or you can shift it to the file sharing repository marked with a star. This allows you to store another 50 gigabytes in between in a S3 bucket that you can use with Boto, the Boto library, if you're familiar with it. Exactly. Thanks for your feedback, Moipi.
So if ever I exceeded the 16 gig that is provided, how am I going to be able to delete that? Where do I go for me to be able to delete that?
Exactly. That's why I said if you exceed it and it crashes, for you there is no option to delete it, or download it and delete it because you're not able to enter it anymore. Here you need to write a support request. In the future, our future solution will be that you will not be even able to reach the final gigabyte, so that this can never happen. So you might get then an error if you write something, hey, you do not have enough space left, but you will always have enough space left for the environment to start up. Is that clear?
Yeah, crystal clear. Thank you so much.
Welcome. As I said, we're currently also, besides that fix, we're adding a require more resources button. So in case you say, okay, 10 gigabytes, the regular storage plus the 50 gigabytes of that S3 storage, that's not enough because I have to work with a lot of data and it needs to be stored in between. Then we can always make something happen to create a special account for you to add more storage. If I say more storage, please consider that it's about intermediate results that you need to store or final results that you need to store. The input data you actually never need to download, and I show you why. We have a plugin called EUDAC. It is the icon with the globe and the magnifier glass. If I click that, you have this plugin, and I just go somewhere in Africa. Let's go to Lake Victoria, to Kampala, and I draw a area of interest. I say I want to have Sentinel-2 L2A data, and I want it from start of September until today, 22nd. And I can now just click generate code. And just like that, I have the entire code, which I don't have to code myself, that is searching for Sentinel-2 data in that area of interest for the current month, September. Because as I said, the data is already there. You don't have to download it. It's all in this EO data directory. But if I click it to open it, it might be very slow because it's extremely huge. It has petabytes of data, all the satellite data, all the years, all the bands. It is extremely huge. It's almost impossible to really find the data manually. So this is why you have this EUDAC feature to actually say, hey, I want to have Sentinel-2 for this area of interest for these days. And the result is then giving you all these elements. It comes with the geometry, the thumbnail to show how much cloud coverage it has. Of course, you can also filter with cloud coverage as well. There are custom parameters. And it also comes with a property called product identifier that returns or gives you the opportunity to get the link, the path to this EU data directory. We have quite a few example notebooks in Dunia Sandbox notebooks. You do not see this directory yet. I will show you how to synchronize it in a second. And if you check out one of these, let's say the water algal bloom, you see how we did it for more efficient data access. Loading a bit slowly because it's a bit big. In the meantime, I will just show you how to synchronize. This button that I'm going to show you is also a bit hidden, so we will put it into a better place in the home page as well. If you click Discover and Wiki, you go to the wiki. So I'll just give you a few seconds so that everyone can go to the wiki page. Meantime, you see the algal bloom directory, algal bloom notebook, and you see how, where did I do it? Here I showed you how you can use the EUDAC feature, and then you go through, here we are. And this is where I get the, let's see, product identifier. This is where I loop through the paths, get the properties, and get the product identifier to get the result path to the EO data directory. But we will do that in more detail tomorrow, so don't be afraid. We will actually do this EUDAC search, then going and trying to create these paths to the EU data library and get the path and read it all in. To get these example notebooks, as I said, you go to the wiki, you then go to the Dunia Sandbox on the left side. And then you have two options. Either you search for example, and I think it's the third result, or you go to NB Git puller, which is here. So Dunia Sandbox and then NB Git puller. And you will see this green button, Get Example Notebooks. We will probably repeat that tomorrow as well. I will copy that link and also add it to the chat. Fortunately, I think this chat doesn't work for me. So I will just put it into the Q&A, although it's not made for it. And if you press that link, it will automatically open up another bar. And now your private working environment, in case you're logged in, is synchronizing with this freely available satellite data, the freely available example notebooks. And now you see all the notebooks that we have. If you click back on Jupyter Hub, you will be redirected back to your sandbox, and you should see the Dunia sandbox notebooks directory on the left side. You can do the same approach with your own GitHub repositories. We also have other Git features here, clone a repository, git clone button. If you have your own repositories and you want to include them, somehow pull them there, of course, you can also always use the terminal to do a git clone, but you can also use the built-in features that we have to synchronize any GitHub, Bitbucket, GitLab repository. In this case, this is also a Git repository and it is automatically synchronized. I will add one or two more examples for tomorrow's session, which are not in there as well already. So you will probably not see the ones that we will work on tomorrow. There was a question by Genealem. I guess this hand was removed. Is there any open question, any feedback, maybe from the ones from the government that said they're from a governmental organization? Are you even interested in a feature like that where you learn how to work with satellite data yourself? Or would you be more interested in a feature that gives you the final statistics, the results based on EO data? I see a hand from Tuku. I allowed your microphone. Please go ahead. We should hear you, but I think your microphone setting does not work right now. Now you're muted again. If you want to, you can also post your question to the Q&A session.
Hi, Johannes. There's some questions
Yes.
in chat as well. So someone is asking, is it free to join Dunia?
Yes, it is completely free, as I said before. So the registration, that you will never be asked for any payment information. So it is for free.
Okay. So
and also if you use the API or the toolbox to just get the streams, that access is all for free as well.
Okay. So Pamela is asking, when using QGIS on Dunia, it is great that all the datasets are available on Earth observation data, but it's hard to know which tiles to select for a particular area of interest when using Sentinel-1 or 2.
Yes.
Also, for the streaming solution, I was looking for a specific flooding date in a particular year, but could not get specific dates within that year. So how do you address that?
Thank you for pointing that out. I will note that feedback down for the specific dates. So currently we are planning a new release for the streaming, that if you are in the streaming service, you in the UI, that you will be able to not just define a specific year, but also specific dates and the location, so that you will be zoomed in, that you say, okay, Lake Victoria, and you will be zoomed in automatically, also addresses and so on. So there are a few feedback points that we got from users that we will implement to improve this usability. Regarding the QGIS request, where you search for data, we will reevaluate our possibilities to maybe include it as well. For now, and this is what we're going to show tomorrow, we will have to use the EU DAC library first to and do a bit of coding to just get a symlink to the data that we need in order to use that satellite data in QGIS. But we are working on a better solution, even either a QGIS plugin that you can use, or a different desktop solution to just go for it. But I think a QGIS plugin would probably make most sense to basically use a EU DAC plugin to get the data. But that's thanks for the feedback. This is well received, and this is a weakness that we will tackle.
Thank you, Johannes. Okay, we
You're
have
welcome.
another question about groundwater modeling and potential zones for groundwater. So he's asking how we can get the data so we can monitor floods and droughts.
So could you repeat what you first said?
Okay, so the question says, I would like to get a data of groundwater modeling and potential zones of groundwater and how to monitor flood and drought.
So it's about groundwater monitoring and monitoring droughts.
And floods and droughts.
Mm-hmm. Okay. So tomorrow we will go dive deeper into potential applications of water and wetland monitoring. So you will get your answer here as well. What I can already tell you is we have a few notebooks already about floods with Sentinel-1, or detecting floods and or basically water with Sentinel-1 and Sentinel-2. At the same time, we also have where is it? It is in the not atmospheric thing. In the agriculture section, we have the drought mapping with the SPI, that's the standardized precipitation index, which is also quite nice for drought monitoring based on what is it called? The Copernicus provided atmospheric data sets. About groundwater monitoring, we do not have an example yet, and also tomorrow's examples do not include the groundwater monitoring. I will still see what I can do until tomorrow in this regards.
Thank you. We have another question. I don't want to butcher the name. CNLM from Ethiopia. He's asking, when using Dunia and working with real data in Jupyter Notebook, how is data security handled? And the second question saying, is it possible to access or download time series data globally through an API? And if so, how? Please show us, if you don't mind.
Mm-hmm. So, as I said, this private working environment is completely private. So if I uploaded this F7 PNG file, if you are currently in your working environment, you will not see this PNG file because it is just in my containerized environment. No other user is able to go into that environment. And we also have quite a few security standards in place in the background to protect that, not just with regular authorization and authentication procedures, but also with a fraud detection mechanisms to see that nobody enters this environment. So we are protected from outside in general. So this is being monitored, and with authentication and authorization procedures, just the person with the respective ID is able to enter his or her private working environment. Of course, with the allowance of that user and the permission of a user, a support can enter it to help retrieve or remove a specific data set. Because of course the administrator will always be able to help, but this would be then still monitored if there is an access from outside, and it will always be communicated and will only happen in case of support and permission of that user. Regarding global downloads, so Dunia was created for African use cases, so the data access was restricted to the African continent. GeoVille is offering the streaming solution not just in Africa, but elsewhere as well. If you are particularly interested in data access or similar solutions in countries outside of Africa, then you can always contact me. You should have my email address, I guess, from this webinar. If not, please ask Grace and she might give it to you. We can talk about that. But in Dunia itself, we're focusing on the African continent because we also want that if people from outside, from Europe, from China, from America, and so on, work with Dunia, they only produce something that helps Africa. And that means that is monitoring or detecting something in Africa. Of course, if that person doesn't share it, it is not really useful for the rest, but that's our hope, of course, that people share what they have created, because we're very eager to create nice success stories. So if you create something in Dunia, and even if you think it's nothing special, it doesn't matter, we would be very happy to create a nice success story of your work that is not just shared by ESA, but also by the European Space Agency and beyond that. I hope that answers the question.
Yeah, I think so. We have another question from Tuku. He was asking, would you please repeat the steps at the wiki page to synchronize the Git repository?
Yes, I can do that. As I said, we will do that tomorrow again, and we will put it into a better place as well. So on the homepage, if you go to Discover, you go to Wiki, and then you're in the Wiki, in the Dunia Wiki. You can also type in wiki.dunia.esa.int, and you will be also redirected to the Wiki. Inside the Wiki, you see the list of contents on the left side, and we're working with the Dunia sandbox. So in the build section, there is Dunia sandbox. Just click it and you will see the Dunia sandbox section here. Now you have two options. Either you click NB Git Puller inside the useful tools, or you do you just simply do a browser search for example notebooks, and you will also come here. So either click MB Git Puller, that is this one, or search for example notebooks. I've also added this respective link to the Q&A session, so just look for the link that I've posted in the Q&A session, and you should be able to click it. And if I just click it, it automatically opens this synchronization. That's it. Any more questions?
There are other questions. Someone is asking, what is the main benefits of Dunia compared to Google Earth Engine?
That's a very good question. It's not the first question It's not the first time we get this question. So, of course, first of all, both are free to use, but the disadvantage of Google Earth Engine, of course, is that you are not allowed to use it for commercial purposes. So if you use Google Earth Engine for commercial purposes, it actually costs. Dunia you can use also for commercial purposes for free. This being said, I don't want to say that Google Earth Engine is anywhere worse than Dunia. Google Earth Engine is, of course, extremely powerful, but it also comes with some drawbacks, of course, because every platform comes with some drawbacks. Another disadvantage or difference between Dunia and Google Earth Engine is that all the notebooks that we are trying to provide to you, all the Dunia example notebooks, they are executable not just in Dunia, but outside of Dunia as well. So you can download these notebooks, and if you have the data sets, and you can get the satellite data sets from somewhere else as well. You can get them from the Copernicus data browser, and in future there will be a lot of solutions that offer that data. With our notebooks, you can execute them anywhere. You just have to replace the EUDAC library. And if you want to keep using that EUDAC library, you can just use the download functionality instead of searching for the EU data directory. Then this notebook still works as expected everywhere you execute it. In Google Earth Engine and also in Digital Earth Africa, for example, you see a lot of modules, a lot of Python modules that if you try to execute them outside the Google Earth Engine or Digital Earth Africa, they will not work because you have to be in that specific environment. Google Earth Engine code only works in Google Earth Engine or connecting to Google Earth Engine, I think, as far as I understood. I've never used it outside, at least. And the same goes with Digital Earth Africa. In future, what we also try to include in Dunia is adding more specific African data sets that are then not part of the Google Earth Engine archive. And of course, we also try to add features that support AI better and are also trying to help decision makers. As I just said, we're really trying to get all the feedback to see what results can we present, statistical results over African regions and authorities to help people do decisions without the need of coding themselves. So we really try to co-design and create something that Africans need. And I think that's a big difference, that we try to get in contact with the people and try to include what they need. Of course, that's not always easy, and everyone wants to have it a bit differently, but give our best, try our best to achieve that.
Thank you, Johannes. We have another question from, it's not a question, he just wants the link to the wiki page. Maybe you can share it in the chat. The next question, is it possible for you to share some of the flood mapping notebooks you have?
The flood mapping what? Notebooks?
Yeah.
Yes. So the current one, so the wiki page is basically put a wiki before our platform name. So wiki.dunia.isa.int, or if you're on dunia.isa.int, just click Discover and click Wiki. For the notebooks, yes, there is. We have a few flood notebooks, and they're getting more, of course. We have not as much as we want to, but we will include 2 new notebooks tomorrow after the event. For now, we have, what do we have? I think we have this Dunia Sandbox notebooks. That's basically our example notebook collection. And inside floods, we have floods with Sentinel-1, and we have floods from Shea Bell River. They are part of those synchronized notebooks. Of course, it is always possible to make it more detailed, more expert-like. Why is it not that way? Because we really try to explain each and every step in our notebooks. It does not help you to see, okay, let's use the function preprocess Sentinel-1, and then I have preprocessed Sentinel-1 images. Of course, it's nice if you have that, because it makes everything more easy, but it doesn't help you understanding the data itself and how to do it yourself, like applying the orbit file, applying thermal noise removal, and so on. And this is crucial to understand the data, to work with it, instead of having this black box and just executing a few pre-made library calls that you are not able to use anywhere outside. So this is why it is a bit difficult to include everything in one notebook each. So we want to split it into several notebooks. And there is a webinar series coming up where we really try to put each and every step into step-by-step tutorials and explain these parts. Of course, you're welcome to contribute to that. If you have examples, then we're happy to include them into these example notebooks for everyone as well.
Okay. The next question is there any option that we are working with into like Google Earth Engine? Okay, I'm not getting the question. But it's about air quality monitoring analysis for I don't know.
So if you connect to Google Earth Engine and you have a Google Earth Engine account and you know how to use it, you should be able to use it. If you can do it in a notebook outside, then you can also do it in a notebook inside Dunia. There is no, we do not forbid that. So you can try and use Google Earth Engine inside. It should work normally using your credentials. For atmospheric input data, we also have examples on that, accessing the climate data, Copernicus, the Copernicus Climate Data Store, I think it's called, CDSCC or something, where you get temperature data, precipitation data, ERA5 monthly averaged data from 1950 to today, basically. So yeah. And our speaker from tomorrow, she did some of these notebooks as well, so she might give you an answer on some atmospheric information here as well.
Okay, thank you, Johannes.
You're welcome.
Someone is asking, is RStudio used within the platform?
Yes. So there are two options. Either you use R in a Jupyter kind of environment like this, but you can also use and have the R console. So here I'm currently in the R console coding in a, and of course you can also go to desktop and start RStudio here as well. Where is it? I think it is in graphics R, I think. This is also the R terminal. There was RStudio somewhere here as well. Need to find it. I'll need I'll have to check that and come back to you tomorrow, because usually I saw RStudio here. Don't know why I don't see it right now, but usually you can use RStudio in the desktop version.
Thank you, Johannes. I can't see any more questions from our chat or Q&A. So I think we can leave it at that for today.
Mhm.
But tomorrow we can continue at the same time. So thank you, Anis, for your
Okay.
presentation.
Great. Thank you so much. It was a pleasure. Thanks for all the feedback. Thanks for all the questions. I really much appreciated them, and I noted them all down, and we will work on all of them. Thank you.
Thank you. We're excited about the AI part of it.
Great.
It will be integrated. Thank you. Thank you, everyone,
Thank
for
you.
joining. Yeah. We'll meet
Bye-bye.
tomorrow at 11 East African time.
Yes.
Okay.
See you
Bye-bye.
tomorrow.
See
Bye.
you.